Hello everyone, I'm back. Part 2 of my digital reality live stream marathon. Luckily the video is back online. Yesterday I had some issues with that. Now it's back, that's great. So you can rewatch part 1 as well. 2 hours of streaming. I mean, when this whole thing is done, I will have 10 hours of streaming material. My goodness, that's so much. Okay, so yesterday I have started building an application, a 3D space in processing. So I hope you know what processing is. It's an amazing software development environment that you can use to create creative coding applications. That means it's an environment for artists and designers to create amazing visuals, but also much more than that. So processing is basically a very fundamental tool to build a lot of different media artifacts, and that's very powerful. Hopefully you followed that stream yesterday. I will just continue developing this application that I've prepared yesterday, and now I will switch over to my screencast, and you should see my desktop. And I'm going to my folder, finding the right place where I just put the code, and this is it. Let's take a look at it. Processing is starting, hopefully. Yeah, here it is. Okay, I also have to write a message to my Discord community to tell everyone I'm live now. And by the way, if you don't know that, I have a Patreon community driven by about 500 people. We are an amazing group of people working with processing and creative coding, exploring this sphere, mostly a little bit focused on graphic design, but not only on graphic design. And it's really a lot of fun. I will now post that stream to my Patreon channel. Let me see. So I have 2 screens here, and you can see what I'm doing here at the moment. Okay. Okay. Part 2 of the stream. Come on, part 2 of the stream. Alrighty. Cool. Okay, this is what we built yesterday, or what I've built yesterday, with the amazing help of some people in the chat, which was amazing. So this is a 3-dimensional scene in processing, quite advanced already, right? We've got some lighting, we've got a dome, so we are inside of a sphere. We've got a dome which has a texture, and we've got a floor, and we can also move here. When I use the buttons S and W, I can move in that scene to the front and the back, which is quite cool, I think. Yeah, and yesterday we discussed how we could proceed with that scene. While thinking about that, I came up with a thought that I now find extremely important, which I would like to share with you. This thought is the following. Let me just see, let me check. I've got my Instagram feed here on my other screen, and I posted something yesterday. By the way, if you don't follow me yet on YouTube or Instagram, just people always say this in YouTube videos, and I mostly hate it, but I will do it now. Also, subscribe to my channel. So I'm sharing also in this year, I'm probably going to share much more YouTube content. Subscribe to my channel and hit the bell, whatever it is. I don't know exactly what the bell means, but people always say hit the bell in YouTube videos. So that's the reason why I also do it. But what I wanted to tell you is that I've just found an amazing quote in Stig Møller-Hansen's dissertation. Stig Møller-Hansen is a researcher and a very good friend of mine, and he's working in Roskilde, I think, in a university teaching creative coding, an amazing person. And he wrote his dissertation on teaching creative coding to graphic designers. And he has an amazing quote in it, which is not his own quote, it's by Mitchell and Baum, 2 researchers who I think also wrote a dissertation on this theme. They said creative coding is a process based on exploration. Let me just bring it up here. Creative coding is a process based on exploration, iteration, reflection, and discovery. So for me, that means that when we work creatively with code, or when we practice creative coding, it doesn't necessarily have to be, or it doesn't necessarily have or need a briefing or a goal, you know, a place where you want to go. Creative coding is about exploration. It's about experimentation. It's about trying things and getting inspired by the process itself. So that's what I really like about this. This is in a way, it is a philosophical process where you reflect yourself based on your experience that you make while fighting with the computer in a way, right? So it reveals your personal, how to say that, your personal relationship to the computer and digital technologies in general. I really like that. I think that's probably the reason why I practice creative coding, why I teach creative coding, because I think it's not really just about making new cool design applications and making new cool visual worlds. That's only the front end of my work. In the back end, you learn how to think about digital technologies. And it's something I find very interesting. But this quote is especially interesting because it says that the process is about exploration, iteration, reflection, discovery. So in this case, I didn't come up with a concrete plan. I didn't say I want to do exactly this or that, right? I said I want to explore the world of creative coding in terms of a three-dimensional world and see what kind of ideas I come up with while being in contact with you via this live stream. And that's something I find very, very interesting to explore. Hope you can follow me. Anyway, I'm now leaving the the space here. I'm just moving here. As you can see, the box just disappeared because it just is now behind the horizon, behind that dome that I've just created, where I just put that background. So again, if you just missed the live stream yesterday, make sure you rewatch it. It's available on my YouTube channel now again, and you can take a look at it if you want. 2 hours. It's a lot of stuff. But I explain, I explain dozens of things, like, how I just approached working with moods in my mood board while developing the scene, how I create a random walker based on Daniel Schiffman's tutorial, how I just built this scene, how to put a texture onto a sphere, and so on. So yeah, that's probably quite interesting for you if you're interested in creative coding. Anyway, let's move on. Now, I would like to put some sketches into the 3D scene. That's what I would like to do now. So I think it would be very interesting to see how we can implement a independent processing sketch that can be placed as a video display inside of the scene. So we have kind of a, later on, maybe kind of an exhibition space that we can walk through and watch various exhibits where processing sketches are rendered on. Sounds super, super advanced, I think, for most of you probably, but it is not, because we have pgraphics, which is a class in processing for creating it's a class in processing for creating independent processing sketches that we can place into the scene as an image. And we have object-oriented programming, which I introduced you to yesterday, so into the very basics. And if we create an object type or a class where we can define processing sketches, independent ones, maybe also based on randomness, so each of these sketches could also really look different, then we can place those images into the scene here and create an exhibition space. Sounds cool, doesn't it? Okay, let's get started. And I am back in a minute. I just have to get something to drink. I'm here again in about 15 or 20 seconds. Hold on. All right. Oh, have to close the door. Okay, cool. I'm excited. Let's do this. All right. So, as I told you, first of all, I would like to remove, and by the way, is everything running here? No, I'm not recording. No, I'm recording. Okay, let me first of all answer some questions. Hello, Sergio, Thomas, Speedwolf. Sander is also nice. Hey, Sander. Thank you so much, Sander. Sander says, a live stream of Tim in the morning. This is going to be a wonderful day. I hope you don't have to work. Otherwise, make sure you don't get any problems in your company. Okay. And by the way, Sander, I'm really looking forward to publish the post. I'm about to post a very, very nice interview with my friend Sander Sturing, who answers some questions about his work at Studio Dunbar as a creative coder, which is super, super exciting because I think he really knows, or you, I don't know who I'm speaking to now, Sander or the others. Anyway, I think you know how creative coding really can be used in a professional environment. I know how many questions arise when this is the case, and you really delivered some very valuable insights into that. Thank you so much, Sander. Yeah, and I'm writing these hours as individual training. That's perfect. Hope you can learn something from me here because you're already very advanced. Cool. Okay, let's do this. Okay, so what I'm going to do now, I will create a class. Okay, don't worry, classes are something very important in programming in general. So classes are a way to construct abstract objects, describe them, and then use them as an instance in your sketch. I know this sounds very, very abstract and very maybe frightening to some of you, but hey, let's do this, and then you can then you can see if it works for you and what kind of questions arise. And no, this is not a stream for absolute beginners. I mean, you can of course take a look at what I'm doing here. I'm trying to explain everything as clearly as possible, but I think if you have never worked with programming, and that's a question from the chat by the way, if you have never worked with programming, this could be a little bit difficult. But hey, that's fine. I mean, if you take the stream to get inspired, to get new ideas, maybe to get inspired to start coding yourself, then that's perfect. Okay? All right, so here is my code. I have some elements here in my scene. I'm putting this box into the scene here, and I will deactivate this code for now because I don't need that sphere anymore. Let's run the sketch and see if I just didn't do any typo here. Okay, cool. Now I have this scene again where I can walk to the front and to the back. Very cool. Now let's create a new class, and I will call this class, I could call it display, or let's call this video wall. Okay, video wall. That's how I call this tab. Right here I create a tab, and inside of this tab I'm going to create a class. This class is called video wall, and classes always, or should be, if you want to work syntactically clean, you should start with an uppercase letter. Video wall, and then I put some curly brackets here, and inside of a class we always need a constructor. So I will create a constructor by saying video wall, parentheses, curly brackets. So this is the constructor, this is the function that is called when we construct a video wall. Okay? Now, Okay, now on our video wall, we have a pgraphics object, which is the independent processing sketch that I want to put in here, right? pgraphics, I will call this variable pg. That's how I always call pgraphics objects when I only have one. So pg equals to create graphics. And now I have to define a size, create graphics. And I've got an amazing idea. We could do a three-dimensional sketch inside of a three-dimensional sketch. Whoa, that's crazy. Let's see if that works. Okay, create graphics. Let's define a size. Let's say 1,200 and 900. That's quite large. Let's start with 800 and 600. That's maybe a bit better. Okay, so I will define two constants, but I have already defined them for colors, so I will use these here, so I don't need to define them again. Okay, that's fine. And I need a function that is called generate, to generate the visual on the video wall, and display. Yeah, okay. So I've got two functions. One is generating the visual and the other one is displaying the visual. I will create two more variables which define the size of the tiles. So okay, let me show you something. I'm going to create a grid and I'm going to into the depth of my, this is a difficult word, depth of my sketching folder, of my sketches folder to, you know, this is my sketches folder. So I've got it sorted by years. The other years are on my hard drive server thing here on the floor. And I'm organizing them in years, which is very helpful because then they don't get too full. Even though this one has 489 files, which is a lot. And I created something, I think it's called grid. Many sketches in my library are called grid, but let's see. Okay, this is another grid. It's not what I mean. Come on. Let's see. Where do I have this kind of grid that I'm looking for? I know that there is a copy of that in my research folder. So I have a research folder because I'm also currently studying digital media and experiment in Bielefeld. Just went back to university with 35 to learn about creative coding and what creative coding actually is. That's my master theme, and I'm very hardly working on this at the moment also. And I have a project in here in doing coding systems code, and there is, as far as I can remember, this kind of sketch. Yeah, this is amazing, right? This is the sketch I would like to put into the scene. So these kind of visuals. But in my case, I would say that we have an aspect ratio of, let's say, 3:4. So we've got something like a landscape format, and then we put 3 elements on the x-axis and 2 elements on the y-axis. That's cool. But it's also, hey, it's probably not super easy. But yeah, let's try. Let's give it a try. Okay. Let's put these two codes next to each other. And all right, this is going to be, that will be possible. Okay, I'm going into the folder, the sketch folder of this sketch here, sketch, so show sketch folder. It's, where is it? It appears here. No, that's my Discord channel. Come on. Here it is. And in there's a data folder, and in here I have all the SVGs that I displayed here in this sketch. Let me just run this quickly. These are SVG shapes, and I would take them all and drag them onto my new, or into my 3D scene sketch. So this will copy all these files into the data folder of that sketch. Yeah, and in theory I can take quite many pieces of this sketch and just drag them in here or just copy paste them in there. I mean, I definitely have to make some adjustments, but I think I can take a few of these pieces here and drop them into this class. So let me just do that. I will take all the variables here, the global variables. Or do you think, well, or do you think should I code it from scratch? Maybe that's better, right? Because you can follow me if I copy paste code here. I mean, that's not really, okay. I think I should code it. I should code it from scratch. Yeah, because I don't want to confuse you. All right, but I will keep these two variables here. So I've got a variable called tiles x and I've got a variable called tiles y. These are constants. That means they never change, and that's the reason why I just write them uppercase. You don't have to do that. This is, yeah, you know, that's clean code, by the way. Clean code is a methodology. It's very interesting to read about and watch videos about clean code. There's someone, just ask Google again. This person who wrote this book is called Robert Cecil Martin, a pretty smart software engineer. And yeah, clean code is a way to structure your code. And it has some paradigms and design patterns in it that you can use to make your code more readable, more reusable, and easier to hand off to other people. So if you struggle with software development, you know, with constructing a software, which you probably do because writing clean code is a lifelong project, then you should take a look at clean code. This is a term by Robert Cecil Martin. There are great YouTube talks of him, and he's a super entertaining person. He's really funny, and yeah, check him out. It's a cool guy. Okay. Again, I've got a p-shape array here. So this is the array where I will store all the shapes. And by the way, this is the setup function here, video wall, of my video wall object. Okay, so this is the place where I put the logic when the video wall is created. So let's see, what do we have here? So deactivate stroke. Let's just copy paste that. I mean, I could write it, but in this case, that's fine to copy paste it. Here I create this array, shape.new p-shape array with 14 positions, right? So this is the constructor of the array. And this is the code that I need to assign the SVG shapes to the specific spots in the array. What is an array? So an array is basically a list of things, right? So we have data types, or you know, single data types like, you know, string and int and float and char and p vector and p graphics, and all these are variable types. But an array is a list of a specific variable type. That means here we are creating an array of the type shape, p-shape, sorry, here we are initializing an array of the type p-shape. So this is an array that can store only p-shape objects. So maybe you can take this as a little practice, and I'm currently working on my course on arrays, and I've got some ideas how to explain it. So maybe take a look in your room or in your surroundings. You will probably see many arrays. I see an array of leaves on my plant. I see an array of furniture here in at the side of my room here. I see an array of keys on my keyboard. So everything can be an array. An array is nothing else than an abstract list of things. And of course, in programming, these things are much less complex than in the real world. So an array is something like a number, like a floating point value or something. In this case, we are creating an array of shapes, of SVG shapes, and this is again the setup function. And here I've got some code that disables the style of these SVG shapes. So that means we can apply the styling of processing, well, how to say that, native styling of processing. So when we use fill and no stroke and stroke, we can use that to style these SVG shapes in our processing sketch. So here I am looping through an array, and I think I explained it yesterday already, but you know, loops are mostly used in programming not to distribute elements on a visual surface, which I explained in my course for Mastering the For Loop, which is available on my website for my Patreon community. But mostly we use arrays in processing to loop over loops in processing to loop over arrays, right? To get every single element out of an array and do something with it. In this case, we assign all these shapes to the specific positions of the array, and here we are just disabling the style of these elements, right? We're eradicating the fill and the stroke of these elements. So here I've got the generate function, and the generate function should be used to generate a new grid here, okay? So that means, first of all, I need to initialize the pgraphics object, PG, because I want to draw on that pgraphics object. So I will say PG equals to create graphics parentheses. Oh, I did that already. I'm sorry. Here, I did that already here. Okay, let me delete that line of code. Okay, then I can start by saying pg.begin draw, and generate, by the way, it's the draw loop of my pgraphics object, and pg.end draw. So everything I want to display on my pgraphics element, I have to use the so-called dot syntax to access this object, to access the pgraphics object. Just checking if my recording is still working. Yeah, it is. Great. So here I start a draw loop of my pgraphics object, and now I will create, or I will use the, let me just quickly save that sketch here. Okay. I will now, okay, I have to save it with a new name, otherwise I overwrite the old state. Okay, digital to reality step 6. So, did it work? Yeah, okay. pg.background, pg. And I can also say something like pg, yeah, okay. This is an older sketch, I think, but that's not a problem. Okay, pg.background bg, and I will use fill pg.fill fg to give it a foreground color. I will deactivate the stroke by saying dpg.noStroke, and now I will calculate the size of a tile. This is this line of code here. I will rewrite it a little bit because this doesn't make sense. It is called tile W, but because the height and the width of these tiles are squares, each tile is a square and they are equal, I will call this variable float. Oops. Come on. I will call this variable float tile size, and I will put it outside of into the global variable scope of this class, and calculate it here in the video setup function, because it won't change over time, I think. Maybe we can later on adjust this, but at the moment I don't want to change the size of the tile, so I will fix it here. Okay, tile size equals to pg.width divided by 3, tiles x. And because this is a fixed value for now, I can write it uppercase, right? Clean code. That means, yeah, that means that the tile or this variable won't change, right? Okay, cool. Now I have to create a nested for loop for int x equals to 0, x is smaller than tiles x plus plus, parentheses, curly brackets, and I will copy that line of code, put it down here, and I will say int y equals to 0, y is smaller than tiles y, y plus plus. Great, and now I already have the nested for loop. I will create a push and a pop function here to create a new matrix, but of course on the pgraphics object, otherwise it will not work as expected. And I think all I want to do now here is displaying an ellipse, just to test things, right? Just to see if that works. But hey, wait. That's smart. Okay, that, you know, sometimes I wonder about my own code and think, whoa, that's smart. Okay, I'm able to write smart code. Anyway, pg dot ellipse parentheses 0.0 comma tile w comma tile h tile size. I'm sorry, tile size comma tile size. And I also have to, well, I can do that later on. Yeah, but I also should translate the x and the y position of the ellipse by tile size divided by 2 and tile size divided by 2 on both axes. Otherwise, because the ellipse is position centered, it would not be in the middle of this a tile, but be in the top left corner of the tile. That would be the center. Okay. All right. Confused enough? Let's see if that works. I mean, hey, let's just try to put that pgraphics element into my sketch. Okay. I've got a code. Let's see if it runs or if I get any errors. Nope. It seems to run. That's cool. And now I will create an object. Here, now I can, look, I now can say, I now have a new variable type called video wall, right? I will call it video wall v. I will do an uppercase V. And now I can say v equals to new video wall, parentheses. Okay, so now I have a video wall here. And I can say something like this. Let me think. I can go to my scene now. And here I could now place this video wall into the scene. So push, push, pop, translate, width divided by 2, height divided by 2, and then image. Oh, image mode, I have to set the image mode to center. Image mode center. And now I can go back to the scene, say image. Now we're getting very close. V dot, I think, generate. Generate is not a good function name at the moment, but okay, let's change this later on. Okay, v dot generate. Does it make sense? Let me think about this. Okay. Okay, what I could do. Okay, let's get a little bit. Okay, let's get a little bit hacky here. I'll make things a little bit advanced and call. Make the nah, I don't want to confuse you too much. Okay, I've got that one. I will say generate. Okay, I got it. Yeah, okay. So what I have to do here is I have to call this function before my image function. So v.generate. And then I have to say v.pg, and that's the pgraphics object. It's, oh my goodness, this is so weird, but that's how it works. 0.0. So I think me see. Okay, this is missing a semicolon. Let's just see if the code works. It doesn't. V cannot be resolved in a variable. Yes, because it should be an uppercase V. Let's see if that works. If yes, then I have to explain how. Okay. Okay, what's wrong here? I mean, we've got that pgraphics element. Okay, I have to wrap this code into this matrix to make it move with my scene, I think. No, why is that? Oh, okay, because then I don't need to put it into the middle, I think. Let me see. I guess I have to rotate it again. Let me just check the chat because I forgot to look at it. Oh, there's some stuff. It does not. Okay, it does not. If you return the pgraphics from the generate function. Exactly, that's what I wanted to do, but I think it could be a little bit confusing for beginners, Sander. Or what do you think? Should I do that? Or save it as a global variable in your class? Yeah. I think it's working. Let's move on here. So I mean it's working. What I have to do now, I guess, is rotating the. We had this yesterday with the box. I think 90 degrees. Let's see. Okay, there's any way I have to rotate this image to make it. Yeah, here we go. And now I have to drag it out of the sand. And I think for now it makes sense to make this whole thing red or something, just to make sure I see the boundaries of it. Yeah, that's Matteo. That's also true. Yeah, could do that. But I mean, it works, right? Here we go. There's this pgraphics object. And now I will drag it out of the sand by saying translate, comma, minus, I think, was it on the z-axis or x-axis? I don't remember exactly. I think it was on the y, on the z-axis. Let's try, minus 200. Yeah. It's just the wrong direction, but this is basically how it works. So I have to drag it out of the sand by saying plus 200 on the z-axis. Yes, cool. Let's say 400 to see the bottom boundary of that thing. Okay, cool. Yeah, nice. Okay. Okay, great. That works. Okay, cool. Now let's rename the function from generate to display because I think we just need one function. Go to the video wall class, create this function void display, and that should work. Cool. And I think using a color in this sketch could be a good thing. So maybe let's stick with red and see how that looks like. I mean, we can change it later on easily. And what I would like to do now, I would make this whole sketch working. So the first problem I have here is that I don't distribute these elements to the yep. I'm not distributing it properly. So this is also wrong. Tiles X is 3 and tiles Y is 2. So now I should have a circle fitting into the grid. Yep, it does. That's good. For any reason, it looks like the whole pgraphics element is rotated 90 degrees on the z-axis. Again, okay, I have to maybe say minus 90 degrees here. Yep. Tamim, welcome. Hey, great. Okay, that worked well. Now let's take, what's this? Oh, that's not the video wall. Okay, here we go. So tile size plus x times tile size. Now I'm calculating the x position. I will exclude this, or I will create some variables to make this a little bit easier to read for you. So float pos x equals to tile size plus tile size divided by 2 plus tile size times x. And I will copy paste that line of code here, put it in here, say float pos y, tile size blah 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 blah. Okay. And here I will use these variables to distribute the circles on that thing. Pos x, comma, pos y. Let's see. Yup, nice. Why is my pgraphics object that high, and why do the circles not fit into it? I don't get it. That's super strange. 800 times 600. I don't get why this happens. That's the size of my pgraphics element. 800 times 600. That means it's 4 to 3. Yeah, Speedwolf, thanks. That's true. Oh, 51 from my previous sketch. Let's see. You mean push? Matteo? Oh, yes, that's true, of course. Oh no, I have it here. I have it in here. Here's my push function. So that should work. Okay, 3. Sandra, what do you mean? 3L2? What is 3L2? What does that mean? Oh. Okay, that's true, of course. Now it should work. Oh, okay, no, nice. Thank you, Sandra. Perfect. I think I will switch to the format to 3 to 2 to make the grid a little bit less, to make the resolution of the grid smaller. So 600 times 400, and then I can say something like tiles x 3, tiles y 2, and that should work well. Let's see. Yep. Great, isn't it? Yeah. And as you can see, the resolution is then a little bit blurry, but that's fine for now, I think. Cool. Okay. Now, let's write the logic into the video wall. So I would like to pick the SVG shapes based on this algorithm here. First of all, I think I can just copy paste that logic here because that's pretty smart. I think I will take it, put it in here, and this will decide what kind of color will be picked. So if random1 is smaller than 0.5, I will, the conditional statement will execute this code here. And in the other case, when random1 is larger than 0.5, it will execute this piece of code. So here I'm kind of laying a foundation, you know, I'm putting a ground onto the shape, right? And later on I will put a SVG element on top of it. So FG, BG, BG, FG. Now here I create a variable that selects a specific element from my array. So I will create, it's an integer because it points to a specific point in the shapes array and takes that one. And here it scales it down. I don't know exactly why. Okay, it could end up in an ugly problem with SVG scaling, but let's see what happens when I'm doing this. And of course I have to put PG in front of it here, otherwise That would not work on my graphics element. Okay. 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 Wow. This is exciting. Let's run the code. Whoa, amazing. Okay, there seems to be something wrong, but the SVG tiles don't match into the grid. I do something wrong here. 10th rate. Okay, but it's probably I have to scale them down. I guess that there is a fourth and fifth parameter in this shape function. Let's see if that's true. Yes, that works. And of course, I don't have to. Yeah, I have to put that code here above that code, because then the rectangles will, come on, put this back here, because otherwise, you know, the rectangles have not been distributed. Okay, I can erase the line of code that translates. Yeah, I can erase this piece of code here that translates everything by the half of tile size to on X and Y, because I don't need it anymore, because I don't position circles but SVG shapes. Yeah, and now I have to, okay, of course okay, I have to think about the colors later on. I will put it back to black, and I also have to scale the rectangles to tile size instead of tile W, because tile W is not a piece, it's not part of this object here. Boom, nice. Okay, can I change the frame rate of a P graphics element? Does anyone know if it's possible to change the speed? Okay, I'm just reading this chat now. Ratios, blah, blah, blah. Okay. Speedwolf, yeah. It's I think it can be annoying, but I think it's really inspiring to hear your opinions how to write this code better. And yeah, it's really cool to see some skilled people here in the chat. It's really, really amazing. What does the scale function do? Nothing. I can delete it. It was a piece of this other sketch. I just copy pasted from here. You didn't specify the size when displaying them. Yep, exactly. Okay, cool. I will also, oops. Sorry. Nice, nice, nice. Okay, how do I slow down the sketch? Speedwolf, you're right. Frame rate of the class or of the main sketch. No, I won't change the frame rate of the main sketch, because I don't want to have it, I don't want to slow it down. What I could do is I could generate a new visual every 600 frames or something, to make the visual just change every few seconds. That could be done. Yeah, that could be done by saying something like this. If frame count modulo 90 equals to 0, right? This is the modulo operator. And I will wrap the whole code in here. And I think that will lead to that this piece of code will be executed every 3 seconds, so every 90 frames. Let's see if that's true. Oh. Yes, okay, so the first frame has been dropped, but that's great, isn't it? I mean, hey, wow, that's amazing. So now I will also put an OR statement in here, frame count equals to 1. Nice. Cool. That's pretty amazing. Okay, maybe I would like to know how the whole thing looks when I just disable the lighting. Let me just see, because let me just show you something. There's a very, very cool artwork I really like, SOD by Jody. And Jody is in media arts, this is a legendary art collective from the Netherlands. And they created this modification of the Wolfenstein game. I don't know if you know that, if you played. So, oh my goodness, there's some advertisement going on here on my YouTube. Oh, I think I should... Yeah. Okay, let me see if I can just... Okay, it's the wrong screen. Here we go. Okay, this is Jody, SOD, and they just took Wolfenstein, which is one of the first-person shooters of all times, and they just replaced all the graphics and made this kind of abstract artwork. So, right? This is a first-person shooter where you kill German Nazis, and Jody just took the whole game and replaced the textures with geometric generative patterns, which is super, super interesting, I think. So I really like this kind of aesthetic, and it really resonates very much with processing. So processing is not Blender, it's not Unreal Engine. It has its restrictions when it comes to 3D, right? We don't have a proper lighting with shadows and drop shadows and stuff, but we can use this as a creative principle. And if we can just deal with it and make something interesting out of it by setting everything to make it more minimal. And I really would like to see if I could maybe take a texture later on, or a shader, to get such an effect. So, by the way, if there is someone here in the chat who is able to understand shader code, please raise your hands in the chat. I would love to ask some questions to you. That would be really amazing, because I'm looking for a dithering shader to put it on top of this sketch. So if you have a shader, if you're able to write shader code, or you know where I can get something like that, please let me know. That would be amazing. So shader are basically filters that we can put on top of processing sketches or on WebGL scenes created with P5.js, for example, to modify how they are rendered. And that can be a rasterization effect, a threshold effect, or pixelization, whatever you like. This is very interesting, and yeah, I think we need something like a shader to make this whole sketch look a little bit more 90s. That would be pretty cool. Okay, I wanted to deactivate the light to see what happens then. Let's run the code. Okay. Can you see? It looks much, it looks much more like a 90s video game. Yeah. Okay. Anyway, all right. Next step. A video wall should have a random position, and that's why I create an X and a Y value. An X and a Z value. And in my setup function of the video wall, I will now assign X to random minus, let's say, 1000 and 1000. I will do the same with Y. And I will also create, Z, sorry, because we will, we want to distribute this video wall. We want to give it a random position in our world. And that's why I will define these two positions. And I also would like to have a rotation, right? I would like to have specify a specific rotation. So I will create a floating point value that is called rot for rotation, or RRT in uppercase, because it's a constant. It won't change over the course of this runtime of the sketch. Rot equals to random radians parentheses 360. Okay, and now I can, yes. Okay, now I can go to my scene and say, translate V, you know, I have to shift things because the whole coordinate system is turned around. V.x and V.z. Come on, I don't know. I don't know. Does it work? Let's see what happens now. I don't know. Okay, it is, for any reason, it is at the top of my sketch window. That means this is the wrong place, I guess. To put that variable, I have to put it here, I guess. But I don't know, but I guess, okay? Okay, let's run it again because it's generating a value that could also be negative, and so that thing could be at the back of my camera, but it looks like it doesn't. Okay, it seems to be at the bottom. Let's just move this plate and see if it's probably at the bottom of the whole thing. Oh, no, it isn't. Oh man, it's so poof. This is crazy. It makes me crazy. How to you know, how to do that with these values? Okay, I gotta fix these values first to make sure. Okay, x should be, let's say, 500, and z should also be 500. Just to test and see if these values work. Looks like I'm using, it's kind of translated on the wrong axis from my point of view, I guess. Let's get back to the scene. 0. Okay, you know what? It's easier to test it with a mouse. Okay, let's create a temporary value here. Let's call it m equals the map mouse x comma 0 comma width comma minus 100 or minus 400 comma 400, and let's take that value here to change the values on each of these spots to see which is the one I want to control. Okay, this is the one I want to control on the z-axis, I guess. v.z, I guess. This is the y value in natural, but here everything is translated, so I guess this should be 0. Sorry, m. I want to test this with m. Okay, yeah, nice. These are the two values I want to change. For any reason. Yeah. Okay, I get it. Okay, of course that makes sense. Yeah. All right. This is the y value here now. Everything is strangely okay. X. Oh, thank you, Matteo. Thanks. Okay, this is very helpful. I will put it into my code. Yep. I guess this is the actual. These are the actual values in this weirdly translated coordinate system. Yeah, okay, but now it works. That's cool. Now, let's again use random values here. And what we could do now, we could now, we could now create an array list. But well, first we have to adjust the rotation of these elements. And then we can create an array list of video walls to place 100 video walls in our scene. That's probably very exciting. And of course we have to rotate it on the, I think, on the y-axis, on the z-axis then, I think, to make it v.rot, to rotate it like this. Hopefully that works. No, that was wrong. Okay, rotate x. Is that the right value? Let's see. Oh, I'm doing it twice. What? Why? Why is that? Okay, sorry. v.rot. I want to rotate it on the y-axis. Okay, this is the x-axis. So I will use rotate z instead. Nope, didn't work. What are you writing? But now you're using the vz value twice and not the vxd. Oh, vxd. That's true. I'm sorry. Yeah. Vx. Yeah. You know, my brain is already very, I feel a bit overwhelmed. But let's do this. This must be possible. Vx300. I guess this was wrong, Matteo. What should I do? What's wrong here? Vx. No, the translation is wrong. That's the case. Yeah. I have to rotate it on the x-axis. That's the line of code that I just deleted. By 90 degrees or minus 90 degrees because it was upside down. What doesn't matter anyway, but let's make things clean here. Okay. And vrot seems to be the right. This also seems to work because it's now putting that element. Ah, come on, where's my sketch window? It seems to work that it rotates it in the right spot. Let's see, okay. Let's use M here to test if I can rotate it on the y-axis. Yes, I can rotate it on the y-axis. Perfect, that's great. It works. Nice. Yes. Thank you, Matteo. Thank you. All right, now let's create an array list of elements here. Array list video wall. So I'm creating an array list of video walls. I will call it walls. I have to initialize this array list by saying walls equals to new array list video wall. This is the variable type that I want to put into the array list, and then I say parentheses, so this runs the constructor of the array list. And now I have to put video walls into the array list. The cool thing and big difference of an array list compared with a normal array is that an array list is flexible. So an array doesn't have flexibility. It has a fixed amount of, or a fixed size. But an array list you can put an element into it and then it will just attach it to the end of the array list, which is super powerful. So for int I equals to 0, I is smaller than, let's start with 10, I plus plus parentheses, curly brackets. I wrote a for loop and I will now say in here walls dot add or push. I don't remember exactly, but I think it's add new video wall parentheses. And this will generate a video wall and put it into the array list. So when this code executes now, I will have an array with, yes, with video walls. And I also can, by the way, I can just activate the lighting again to make this whole scene a little bit more, you know, looking better. And all right, I've got an array list with walls in it. Now, instead of displaying one single wall here, I don't need that value anymore. I will now create a for loop in here that says for int I equals to 0, I is smaller than walls dot size parentheses, which is the size function of the array list and which returns the size of the array list. I plus plus parentheses curly brackets, and I will put that code in here, right? So this will put all the walls in here. Now I have to extract one of these walls out of this. I will say video wall w equals to walls dot get parentheses, and then I will put I in here. So this will take one of the walls out of the array, and then I can say, instead of using v, I will use w, and I also can I can delete the whole video wall v object because we don't need it anymore. v.new video wall, I can delete that code. Let's run it and see if it works. Nope, it doesn't. Oh yeah, because here I also have put w in there. Boom. Nice. Rotation doesn't work yet. Nice. But cool. Hey, this worked. Amazing. Okay, let's adjust the rotation problem here. Let's see what's wrong. Video wall rot equal to random radian 360. Okay, that should return. Let's print line rot when a object is created. Okay. Why is that? These values seem to be a little bit weird. Ah, okay, because I generate radians values, of course. Ah, of course, I'm using the radians function twice. That doesn't make any sense. So now it should be rotated. Let's see. Yep. Nice. Great. Okay, let's change the speed of the video wall algorithm a little bit to a predefined value. Let's say int modulo equals to, in the video function, in the constructor we say modulo equals to random parentheses, and we'll have to convert it into an integer. 5, comma 60. So this will generate a random value between 5 and 59. And we use that as a modulo. So each of these walls should have a different rate, how it changed these motifs. Can you see that? This one is very fast. This one is much slower. Yes, cool. Nice. Yeah, cool, nice. All right. I think it would be interesting to have a camera to control a bit of the angle with which we look into the scene. Whoops, And I also will now take this whole code here, put it into a zip file and put it to my Discord server so you can play with it if you want. Okay, wow, come on. So live streams, 3D gallery, blah, 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 code, 3D gallery, okay. Now, here we go. I will save this to digital reality step 7, and I will hand out step 6 now to you by compressing the whole package and uploading it to Discord. I've got some messages by sender. Okay, there's something else. That's good. Okay. So it's in the students only channel now. You can get it on Discord. Whoops. Uploading, and here it is. Okay, 5.96 megabytes. Should arrive now in your Discord application. Okay, let's implement a point light. A camera, sorry, a camera. So I've got a snippet on my website. So if you're logged in on my website, you can go to snippets. Or you can go to the third dimension course. Maybe that's much easier. Go to courses and then you go to the third dimension, and there's a lesson about the camera. So the camera and processing. It's a weird thing. It is, this is the code for the standard camera. Let's just copy paste it and put it into our processing sketch here. This is the standard code. To be honest, I can't explain exactly how it works. I understand a few of these things here, but not everything. So basically a camera has two different vectors. One is the eye that I'm looking through, and the other one is the place where I look at, right? And if you change these two vectors, which are basically two points in the three-dimensional coordinate system, it changes how the camera looks into the scene. And this is the code I always use for my camera, right? And what we can do here now, for example, is to manipulate the X. So this won't change anything because this is the standard camera, right? It won't do anything with our sketch. But we can do something like this. So plus map mouse X, comma 0, comma width, comma minus, let's say 1000, comma 1000. Okay. Come on. Cleaning it up. And look, now I can move the camera. That's cool, isn't it? I can move the camera now and change the angle that I'm looking into the scene. It's very interesting. Using tan waves to change camera positions is also very interesting, and yeah, it's pretty cool. We can have a control with our mouse and our keyboard to just change the whole scene here, the perspective into the scene. And by the way, I just would like to know how it looks with a different background. I mean, with another image. Let's take. I've got 3. Let's take 1, for example. I think this should be much lighter. Okay. Yeah, this looks quite cool. But what I still have to do is okay, some messages. What I still have to do is to fix the problem that the shadow is on the texture of the sphere. I think there's a hack we can use here. It's a little bit strange. We can deactivate the lighting for specific shapes. Does anyone know how that works? Just let me know in the chat. Okay, Yeah, Rhizome is an amazing archive. Rhizome has an amazing archive of net art. And by the way, I've been researching recently pretty much about net art. Rhizome.org is an amazing place to go And they have this cool book called Art Anthology. It is sold out, but it's a really nice compendium of very interesting net art projects from the 90s and, you know, until the current times. And I think they have this archive anywhere. Let me check. Exhibitions. Okay. Nice. So you can go to exhibitions and explore net art. So basically, Rhizome is a net art initiative by the New Museum in New York, and it's basically the most or the largest net art collection in the world, I guess. And there's also something I would like to show you. I have on my GitHub, I've shared some research results by my own research about net art on GitHub. Let me just sign in here quickly. So my username, I think I know my password. Yay, nice. I know my password. Out of my mind. Great, isn't it? Okay, blah, blah, blah. So I don't use GitHub that often. I sometimes use it to host websites. And there's something I created called Net Art Marathon. Yeah. Web art directory. I think that's it. There are two different. Hey, there are two different. Okay, this is it. So this is my web art directory. I will put it into the chat here so you can check it out. It's a collection of old and new net art projects that can be experienced in the web browser. Very interesting stuff. I really love that. So it's really, really cool. Let me just post it into the chat. There it is. And yeah, I built this application with JavaScript. Yeah, and there are also some of my works in there. So check it out. Let me know what you think. Okay, cool. Nice. Video walls are working. That's pretty amazing. And now think of this. I mean, we could now integrate, instead of just displaying some two-dimensional shapes on these video walls, we could implement something where we have three-dimensional scenes, right? So think of a scene in a scene. Maybe we can take the same scene as here and put it into a video wall. My goodness, that would be crazy, I think. Anyway. All right. Cool. What if we use a point light instead of a directional light? So at the moment, the whole light comes from one side. But what if we have a light in front of us that just illuminates the scene from the camera, just like a flashlight? I think that would be very interesting. I've never used point lights in processing yet, but let's check it out. Processing point light. Okay. 3 vectors and then the coordinate of the light. Yeah, makes a lot of sense. Cool, let's do that. Because we are using the camera now, in theory we would have to also change the lighting position with the camera, but let's start easy with this thing. Let's go to scene. Push, pop, push, push. This is the place where I translate the whole thing. So this is the place where we'll put the point light camera, point light, parentheses. And here I will use the same. I will use width divided by 2 and height divided by 2. And camera Z, comma, and then I have to define the okay, these are the colors, these are the vectors. Okay, so that means I can now use 255, 255, 255, and that should do the trick. I will now deactivate the directional light here in my main sketch, and let's see what happens now. Okay. So the closer I get to these elements, the lighter they get, of course. This one is not receiving any light for any reason. That's because I'm not, yeah, of course, that makes sense, because I'm not binding the position to the mouse or the camera, but I can do that by creating a variable. So taking this code here, putting it into a variable, let's call this float m equals to this. Yeah, okay, this is not a good variable name, but okay, that's fine for now. And I will put it to the position of the lighting here on the x-axis. Okay, it doesn't exist. That's because the variable is not global. I will put it into the global variable scope, float m, and this should do the trick. Let's see. So the lighting now should change with the camera position. I like that. I mean, it's pretty cool that everything becomes very, very much lighter. But what I don't understand is why the sphere at the back is completely light. So I was expecting that I will be in a very dark room. I don't exactly get why the dome at the outside is why it is light. I don't get it. Do you have an idea why that's the case? Let me just check the chat again. Oh yeah, okay, cool. Heather Graham is a PhD lecturer in Sunderland University who has been writing about this stuff for a long time. Okay, cool. Gotta put that onto my notes here. Typora is an amazing note-taking application. I highly recommend it. It's cross-platform, working on every single operating system. Very, very cool. I love it so much. It writes just Markdown. I love working with Markdown. It's, you know, cross-platform. I don't have to care about broken documents and stuff. It's really cool. Okay, notes. I will call this stream notes.md. Okay. So, okay. Well, I don't know why. I mean, it looks great. it looks pretty amazing, I think. I don't exactly understand how this lighting works now, but hey, for any reason, it looks a little bit realistic, and I like that. Maybe I can put the direction light back into the scene, but maybe dim it a little bit by replacing these values to 100. So it won't be too strong. Okay, now the back gets much darker. Okay, that's cool. Wow, that's amazing. That looks nice. Interesting. Yep, interesting. Let's change the color of the video walls. Let's give them a very distinct color. So we are at the moment working with black here. Exactly, because we are working with FG and BG variables from the main sketch, but I will create another variable now, which is called video wall FG equals to FFFF, or let's say FF0000, and I will create another variable called BG, and I will make this one black. Or maybe we could also take my programming posters blue. That could be a cool. Well, let's use internet blue for now. We can change that later on. F1, F1, F1. video wall FG. I will replace these variables down here now with BG and FG. Where is it? So FG is here, FG is here, and this also should be BG. Okay. Okay, so this makes sure that these elements just, you know, pop out a little bit of the scene, so they are more in the foreground, and also it makes the scene not look that dark. But at the same time, what I don't exactly like is that they receive, I think this doesn't work well with shadows now. It just disturbs me a little bit. So the lighting makes the whole thing here a little bit, I don't know. I don't know. But I think, you know, we are already pretty far with this system. So what I also could do now is I could maybe create a logic. Well, let's reset this to black, because I think this didn't work. At the moment, I think we should have a solution, a get a solution for light, because otherwise the whole scene will look very, very dark. But at the same time, I mean, this looks quite cool. Let's create a algorithm to distribute these video walls. Yes. Okay. So let's make the video wall receive an integer. I will call this integer s. Okay. And I will create an integer here, which is also called s. And this will get an underscore. Oops. And here I will say s equals to underscore s. So this, I want to pass a variable into the video wall. Okay, when I create it. So here it already yells at me and tells me that I missed to put an value into the constructor, and I will pass I in here. Now, I will control how these elements get distributed here. This is the place where I have to do this. So x, okay, if, first of all, if I is modulo 2 equals to 0, then do this. Okay, otherwise do that. So, and then I will set the rotation to 45 and minus 45. To make sure they have exactly the same angle, but mirrored. And then I will control the X and Y position by saying, okay, Z is the Z position of that element. Is that true? I think so. Yes, okay. So Z should be not I, but S. Yeah. Yes, yes, yes. Okay. Z should be S times, let's say 200. And X should be when it, yeah, it should be minus. I know you can't follow me at the moment, but I just want to try something out here, which I cannot explain yet well, but I think this will distribute these elements into 2 rows. Yeah. Let's see if that's true, if I'm talking bullshit. Oops. Nope. What's wrong? Well, the rotation did work, but it looks like I have to rotate the whole thing. Okay, let me just draw something onto my Figma document, so maybe then you can follow me again, because I know this is very hard to understand what I'm doing here, but what I want is the following. I want to create a room where, come on, not a room, but a scene. That's the right term. I want to create a scene which is kind of organized as an exhibition space. And by the way, this is Figma on Linux. It is super, super edgy and buggy, but it works, which is great, but it's super, super buggy sometimes. So I guess when this thing loaded, it will work properly. Come on, Figma. This is the only drawing application that I have on my system, so I guess we will have to cross our fingers that this is going to work. Okay, here's a space where I can draw onto. Okay, look, this is the scene. We have a plate. This is the black space, right? And we have a camera, which is kind of a vector. So let's say this is the camera, right? This is the thing we are looking through into the scene here. So instead of having random displays, randomly placed video walls, I would like to have something like this. Maybe, yeah. Can I mirror that one? Oh, I don't care. Okay, let's do it like this. So yeah, I would like to do a scene like this so that we can take the camera and go through the scene. Also look to the left and the right, and to look onto the sketches on these video walls, right? And we can move on this axis here through this, how to say that, tunnel, gate, I don't know. In German we say Gang. I don't know exactly how to say that, but you know, I just want to walk with the camera through this level here. I solved that once in, you know, a few years ago, but I don't know exactly how to do that. To be honest, I fear I'm already a little bit tired already by speaking all the time, coding all the time here. So I think it's very clever to make a point here, move on tomorrow, but we've got an amazing setup now and we can do so many interesting things with it. So once this is finished and we tweak the values, things are probably going to be very, very interesting. Yeah, thank you so much for watching. Thank you so much for joining the stream, and I'm very much looking forward to see you tomorrow at 10 a.m. on my YouTube channel. Let me know what you think in the comments. I hope YouTube won't take down the video again like yesterday. By the way, it's back again. It's back online again, and I will also work on a supercut, which I'm probably also going to post here. So stay tuned about that. I wish you a great day, and I would say see you tomorrow, hopefully. Bye-bye.